All right, Algebra 2 for 5.4. I'm going to make this lesson kind of short, even though it's a little bit longer in nature, but I'll do more in class. But I just want to get you guys the basics here. So 5.4, analyzing graphs of polynomial functions. So we're going to graph polynomial functions, locate their zeros, and find their maximum and minimums, their relative maximum and minimums. So what that means is, if you have a picture of a graph that looks something like this, the relative maximum is going to be like this place. It's going to be like a peak, and the relative minimum is going to be a valley. Okay, and then the zeros are going to be, again, the places where the graph crosses the x-axis. Okay, so let's look at that. Graphing polynomials. To graph a polynomial, you're going to graph just like you do with anything else. You're going to make a table. Okay, so you're going to make an xy table. Some people do an f of x table, right? Depending on the notation you want to use. And then once you get these points, you're going to use a continuous curve. So, say we have a graph, we get all these points that look like this. You're going to connect them using a continuous curve. And then you can use your end behavior to tell whether or not you're done, finding various points on this thing. So just a quick reminder, if you have an positive even function, the graph is going to go up in both directions. If it's a negative even degree function, and by the way, I should give you an example of that. That would be like 2, and I won't use an even number because that may be confusing, like 3x to the 4th power. Okay, that's an even because the degree is even. The degree is what determines the end behavior. Okay, the positive sign tells me that it's going up in both directions. So if it's negative even, like negative 3x to the 4th, then the end behavior goes down in both directions. Okay, if it's positive odd, like 3, well, now we'll change this so that doesn't get confusing. 2x to the 3rd, it's going to go from left to right, it's going to go up. Okay, so it's going to do something like this. And notice the end behavior is opposite for odds. Okay, so it's going opposite end behaviors. And then for negative odd functions like negative 2x to the 3rd, then from left to right, it's going to be going down and in opposite directions. From left to right, you would read it, it would be going in the negative direction. Okay, so that's going to help us with this. The location principle is the one thing that I want you guys to take away from this lesson, and that is this. Like if I have a number of xy pairs, okay, let's say that at like negative 4, I get a y value of negative 2, right? And then if I plug in a negative 3, I get a y value of 1. Notice if you were to graph a picture of this, if you go from negative 2 to 1, somewhere in between these x values, there had to be a 0. What does that look like? Okay, so if we have at negative 4, we're at negative 2. Okay, and then at negative 3, we're up here at 1. Okay, we know that the graph had to cross the x-axis between them. So if the sign changes, the location principle tells us there had to be a 0 that happened in between there. So if this was truly what was happening, I could say there's a 0 between negative 4 and negative 3. Okay, so that's what the location principle is, and we're going to use that here in example 2. So it says determine the consecutive integers between which the real zeros happen, right? So to help us save time, I've already run all these calculations, but I'm going to show you one of them just to show you how this works. So we're going to choose x values, we're going to plug them in, and depending on what we get out that will kind of help us determine if we started in the right place and how far we need to go. So if I plug a negative 1 in, okay, so make sure you use parentheses, negative 1 to the 4th minus 3 times negative 1 to the 3rd minus 2 times negative 1 squared minus 1 plus 1. That goes away. Okay, I've just plugged all these in. Negative 1 to the 4th is 1. Negative 1 to the 3rd is negative 1. Negative 1 times negative 3 is positive 3. So I have 1 plus 3. Negative 1 squared is 1. 1 times 2 is 2, so we're going to subtract 2. Okay, so when I plug in a negative 1, I get 1 plus 3, which is 4, minus 2, which is 2. So at negative 1, I'm at 2. Okay, if I plug a 0 in, everything goes away except for this. So at 0, I'm at 1. Okay, And if I plug a 1 into this thing, I actually get a -2 out. So at 1, I'm at -2. And then if I plug a 2 in, I'm at -13. Okay, so you guys can do some of that math. If I plug a 3 in, I get -14. All right, I've already done it for us here just to kind of save time. And then at 4, I actually get a +32, which is like way up here someplace. Now, the interesting thing about this picture is this. I know, like if I were to just connect the dots right now, I want to show you something. If I connect the dots right now with what I know, what I would have is this, right? I would have this type of thing. We don't know exactly where the bottom is, but something like this, right? So we'd have something like this. By the way, this was 37. So something like that is what it would look like. But look, we have our power function here is positive even, which means I know on the other side of this graph that it also has to go up. Okay, so without plugging too many other things in, I just kind of know, okay, this thing has to kind of go that way. I might try to plug in like a -2 just to make sure it doesn't cross the 0 again. So -2 might be one that I plug in there just to make sure. You can also use Desmos to kind of help you with this. That's kind of what you have to do to make sure that you get, you know, a rough sketch of the whole picture. You got to use your power function to determine end behavior. Okay, so I just knew that it was going to end like this because of that guy, and I knew it was positive. Okay, so here it says they want to know where are the zeros. Okay, so the 0 happens somewhere between, notice here, from 0 to 1 we had a sign change. So we could say between 0 and 1. And then from 3 to 4 we had another sign change. Okay, so I like to go until I see that thing acting in behavior that I know it's supposed to act in. That's how I knew I had to keep going. Okay, so between 3 and 4 we have zeros. Okay, somewhere in there. You can also use a graphing calculator, Desmos, something like that, to kind of help you know, where to stop. Like it can kind of help you can use that as a guide. But on your test, you'd have to have a TI. All right, so for extrema, this is like the turning points and where the, as I said earlier, where the relative maximum minimums happen. These are called turning points, okay? And an important thing with turning points is this. If I have a power function of like, say, let's just say it's like 5x to the 4th. This thing will at most have 3 turning points. Okay, and that has to do with, well, at most it will have 4 zeros, right? So it can only turn 3 times. Okay, so if no matter what the degree is of the power function, if you subtract 1, that's how many turning points it has. All right, so let's look at an example here. Okay, if I want to, now that I know a little bit more about this, without even drawing a picture here, I know that this is going to act like this. It's an odd function, it's positive, so its end behavior is going to look like that. Okay, I know that it's a degree 3, so at most, it's going to have 3 zeros. And at most, it's going to have 2 turning points. Okay, so I know all that before I do anything. Okay, then it says estimate the x-coordinates at which the relative maximum and minimum happen. So I could, go down this list and choose values for x and y and try to figure this out. I'm going to let you, and I think on the test I do this as well. Once you're done with the first page, this is on the second page, I think I'll let you open up Desmos if you don't have a grapher. I really encourage you, though, to get a TI, if you're going to take a math class in college at least. But anyway, with Desmos, you can graph this, and you can look, as long as you know what relative max and min mean, you can get a picture, and you can actually click right here at these points, the peaks and the valleys, and they're looking for the x values at which that happens. Okay, so here I gave you guys a picture of what you would get on Desmos. So here the x value of this peak happens at -1. So at -1 there's a max, a relative max. And then at this point down here, this looks like 2/3. At 2/3 we have a min. Okay? they say to estimate it. So like if you were to do this on an XY table without technology, you might estimate that this turning point here happens at like 1, for instance. And so if you do that on the test and you show me the values that you're plugging in here and you get close, like if you chose 1 instead of 2/3, I would give you full credit for that. All right, so I think that's all I'm going to do, even though example 4 is fun. I was talking about fax machines and their annual sales, and they have this function of how their sales are going down over the years because of improved technology. So they have you graph this function, okay, and you'll do one kind of like this on the homework, all right? The graph that I give you on the homework, if I give you one of these, will help guide your thinking. So you might plug in you might choose, choose a bunch of values here. Maybe you choose 2, 4, 6, 8, 10, plug them in, get your values out, and it's going to be in millions of dollars, right? So then you would graph this, and then there's a number of questions I'll ask you about this. So look, last thing I'm going to say on here is this. Your test is made up of 2 questions. 2 questions, okay? So what I do is I have you graph one of these polynomial functions. So you just choose x values, plug them in, get the y values out. Then I have you tell me what are the approximately where are the zeros? How many times does it turn? What is its end behavior? I'm going to ask all of those types of questions. And then the other test question that I'm going to ask you, so I'm going to have you make a table, graph it, and then the second question is I'm going to tell you to sketch a degree, 3 or 4 or maybe 5 function, and I'm going to tell you where the zeros are. You have to, in order to get that question right, what you have to do is you have to, like say I say, sketch a degree 4 function. A degree 4 function with zeros, and I might tell you where the zeros happen, right? With zeros at -3, -2, 1, and 6. Okay, so if it's degree 4, and I have zeros here like this, and I think that's all I'm probably going to give you. And I might tell you where a maximum happens. So maybe I say like a max happens at 0. Okay? So in order to do this, what I would do is I would go ahead and at the zeros, I would put points. Okay, so at -3 we had a crossing, -2 we had a crossing, at 1 we had a crossing, and then at 6 we had a crossing. Okay, I know this is a degree 4, so in this direction and in this direction we're going in the positive. Okay, so since that is the case, and I know that I have a maximum here at 0, then I know that this thing could come down through here, could go up through here, could come down through here, and do this kind of W shape. So be comfortable, and I think there's a couple homework questions related to that. Be comfortable doing something like that and sketching one of these given some parameters. All right, guys, that's it. We'll see you guys in class next time.